And so this is just sort of to get your feet wet using Excel and making some plots. And so the idea here is that the plot that you make would be like a plot that you were going to make if you were writing like a peer-reviewed journal article, or if you were doing a lab experiment, writing a lab report, something like that. And so this is part of what would be in a lab report if we did this experiment. The data that we're looking at was collected by a different ME1800 class. But I'm going to select both of these two columns. And I'm going to go Insert, Chart, and I want a scatter plot. And so that has created a plot where I have plotted the feed rate. So this is the number that's 0 to 0.9. And so the units for that feed rate should say up here is millimeters per revolution. And that feed rate versus the RT. So the RT is a measure of surface roughness on the part. We've cut apart with varying feed rates. And we've measured using a surface metrology instrument this RT value. The first step was to make the plot and then to put labels on the axes of the plot. Quick way to do that would be to go to the Quick Layout button and choose a layout that has labels on it. And then you can go edit these. And so this is feed in millimeters per revolution. And this is RT in micrometers. Pay no attention to the fact that I used a U instead of a mu. So download the data, create an XY scatter plot, label the horizontal and vertical axes. Okay. Oh, create a title for the plot. We could call it RT VS feed. Yeah, that's a nice title. And I suppose I could put the units for feed there. Add a second order best fit trend line to the plot. If I come back over to Excel, if I right click on a data point here, I could say add a trend line. There's trend line options. I would like a polynomial of order 2, second order polynomial fit. And I want to see the equation and the R squared value. All right, what else do I need to do? Put the equation and correlation coefficient R squared value on the chart by the trend line. Plot and label the theoretical curve for RT equals F squared over 8R. So our R from the assignment here is 0.8 millimeters. Our formula, RT equals F squared divided by 8R. So what we can do here is add a column. Theory. So R is 0.8. So our theoretical value equals F squared, so that's feed, F squared, the whole thing, divided by 8 times R. And I would like it to always pick this particular cell, not copy down later. So I'm going to say E1, but I'm going to put a $ before the 1. And a $ before the E, because I always want it to refer to that value. And yes, I want to correct my mistake because I forgot to close the parentheses. And then I can copy this down. So what I did is I mouse over until that changes to this little plus sign here, grab it, copy it down. And so now I have a measured value and I have a theoretical value. What do you notice right away about them? they're different by orders of magnitude. So this measured value is micrometers. Our theoretical value is inches. Or sorry, not inches. That would have been really stupid. It's millimeters, right? What's the difference between millimeters and micrometers? It's 1,000. So I'm going to take the whole thing times 1,000. And I'm going to make sure that it's the whole thing. And now at least it's a similar order of magnitude. Not the same number, but a similar order of magnitude. All right. So I've got a theoretical value, and I can now go to my plot. I can right-click, select data, add. The x values are feed. The y values are this theory column. And my series name is, you could write theoretical, but I'm afraid I won't spell it right. And so now we've got our measured values and our theoretical values plotted here, and you could put a trend line on these if you wanted to. Oops, but it shouldn't be linear. Format trend line, polynomial order 2. I'm not going to bother to set the, so anybody know what the R-squared value is going to be on this? It's going to be 1. If it's anything other than 1, then Excel's broken. And I'm not going to bother to put the equation up for now. There we go. So now we have our data points plotted, the trend line plotted, the equation for the trend line plotted, and our theoretical data plotted. What's the last step? To submit an image of the plot you created. So don't save the Excel file and give me the Excel file. What I want to see is, let's use the snipping tool. What I want to see is that for the answer. So the image of the plot that you created based on these things. Should be pretty straightforward. It'll get you to exercise a little bit with Excel. If you haven't done these kind of things before, feel free to play around with it. Feel free to check different things, try different trend lines. On Thursday in class, we'll be talking about the theory and the rationale behind that equation that we used. So you don't have to, in order to understand how to implement the Excel part of it, you don't have to understand why the equation exists. But by the end of the day, Thursday, you should understand why the equation exists also.